So the next section we're talking about some other important segments in a triangle. So first we're going to just talk about what it means for something to be concurrent, right? And that's when three or more lines intersect at the same point. Okay, so throughout this section we're going to talk about points of concurrency, and that's just saying for that specific segment that we're talking about, what is the name of the place where all three of those points intersect. Perpendicular bisector of a triangle is the same thing as the idea behind a perpendicular bisector of a side. It just takes place in a triangle. So it is both perpendicular and it bisects the side of that triangle. When we talk about point of concurrency, when the three perpendicular bisectors of a triangle intersect, when they meet, we call it a circumcenter. Right? A median goes from the vertex of one side of the triangle and it bisects the opposite side. The point of concurrency for this is called a centroid. And as you can see, these are just three different examples. Alright, and we're not going to get too much into any of this stuff, so don't worry too much about that. Again, we're not really going to do any math on this, so don't worry about that. We're just going to go with definitions for this chapter. Let's skip right through that. And lastly, there's an altitude, and the altitude of a triangle is going to go from the vertex of one. I'm going to go from the vertex. Let's try that again. It's going to go from the vertex and it's going to be perpendicular to the base. And again, the point of concurrency for that is called the orthocenter. And that's really all we're going to talk about for that. So if we take a look at these examples, which are not in the paper, you can just follow along with the video. All right. Looking at 3 through 7 here, we want to know, given this information, would this segment be a perpendicular bisector, an angle bisector, a median, or an altitude? Okay, so DG is congruent to FG. Okay, if that's true, because EG is starting at the vertex and it's bisecting the other side of the triangle, that would make this a median. Okay. For number 4, if EG and DF are perpendicular, then because EG is starting at the vertex and it's perpendicular to the base, that would make this an altitude. Okay. For number 5, we have angle DEG is congruent to angle FEG. Because it is bisecting the angle, that would make it an angle bisector. Okay. EG and DF are perpendicular, and DG is congruent to FG, would make this a perpendicular bisector. And triangle DGE is congruent to triangle FGE, would mean that these pieces are congruent to one another, okay, which again will make this a median. Okay, if these were congruent, because this is 180 degrees, that would make each of these have to be 90 degrees, so it would also be a perpendicular bisector. Again, if the two triangles are congruent, these angles would have to be the same, which also makes this, the perpendicular also makes it an altitude. And lastly, because of the angles, it's also an angle bisector. Okay, and that's all that we have to do in this section.